Hi and welcome to the section Implementing Properties and Events in our Components. Let's proceed with the first video, a better template syntax. Here we'll take a look at the way Angular solves the problem of injecting data in and out of our components through quick and easy examples. Please focus on the philosophy behind these properties. We'll have a chance to see them in action later. Let's revisit the timer component functionality that we already saw in section 1, creating our very first component in Angular. Please note the attribute wrapped between brackets. This informs Angular that this is an input property. We can inject a data variable or an actual hard-coded value, in which case we'll have to wrap it round single quotes within the double quotes, should such a value be a text string. So, go to your working directory and open the file app.component.html. Once here, add these lines of code. We use this very bracket syntax to make native HTML attributes reactive to component fields. So, if we change the hidden property as false, the text specified here will be visible. Now, if you go to the browser and run the localhost, you'll see the text displayed on the screen. Let's go back and check what happens when we change it to true. And here, it got vanished. The Angular team has made some shortcuts available for performing common transformations in our component directives and DOM elements, such as tweaking attributes and class names or applying styles. Here we have some examples of great time savers when declaratively defining bindings in our properties. In the first case, div will enable the hidden attribute should the isHidden expression evaluate to true. Here we've changed it to the Boolean value false. Besides Boolean values, we can bind any other data type, such as a string value. In the second case, the isValid class name will be injected in the class attribute if the isValid expression evaluates to true. In our third example, div will feature a style attribute that shows off a width property meant to be set with the value of the myWidth expressions in pixels. Now, when you switch to the browser, where we are running the localhost, you'll find the input field added to the page. You can find more examples of this syntactic sugar in the Angular cheat sheet available at the official Angular site. Let's imagine we want our timer components to notify us when the countdown is finished, so that we can perform other actions outside of the realm of the component. We can achieve such functionality with an output property using this line of code. Note the attribute wrapped between braces. This informs Angular that such an attribute is in fact an output property that will trigger the event handler we bind to it. In this case, we'll want to create an onCountdownCompleted event handler on the container object that wraps this component. By the way, the camel case is not a coincidence. It's a naming convention applied to all output and input property names in Angular. So, for the onCountdownCompleted container, we'll create a reference in our appcomponent.ts file and call the container. Here we can add an action or add an event to it. We'll find output properties mapped to interaction events that we already know, such as click, mouse over, mouse out, focus, and more. For instance, we add an event do something. Now, go to your app component and add the event here as well. We also get an alert message, button clicked. In component.html file, you can see that the event is created. Next, go to the browser and click on the button. You'll see that the alert is generated automatically. The best way to grasp the concepts detailed until now is by practice. In the first section, we learned how to build an application from scratch by using either Webpack or Angular CLI to set up the project. Let's quickly remind ourselves of the anatomy of an Angular project, so we know what to do with all the new constructs we're about to create. Here we have two files which are of extra interest. Main.ts. This file bootstraps our application. App.module.ts. This file declares our root module. Any new constructs will have to be added to the declarations property of this module, or you'll need to add a dedicated module for those future constructs. It's generally recommended to have a dedicated module for new constructs. We have. We mentioned the concept root module. We mentioned this concept to remind ourselves of Angular modules in general. An Angular module holds a bunch of constructs that belong together. You'll recognize an Angular module by using the ng module decorator. The module itself is just a plain class. The ng module decorator takes an object literal as input, and it's within this object literal that we register everything that belongs to the module. Let's strip down the timer example that we saw in the first section, creating our very first component in Angular, and discuss a simpler example. Create a new file and name it countdown.component.ts. Let's add the component class to this file. Great! We've just defined a simple but highly effective countdown timer component that will count down to 0 from 25 seconds. A simple set interval loop executes a custom private function named tick that decreases the value of seconds until it reaches 0, in which case we just clear the interval. However, now we just need to embed this component somewhere. So let's create another component with no functionality other than acting as an HTML wrapper host for the previous component. Go to the timercomponent.ts file and replace this code. Once done, go to the app.module.ts file, and as promised earlier, we also add our newly created components to the declarations array of the module it belongs to. The reason for doing this in the first place is to ensure that these components are made available for another, as is the case with countdown timer component being used inside the template of timer component. Components in Angular are basically directives with a view template. We can also find directives with no view, which basically add new functionalities to their host element, or they just act as custom elements without a UI that wraps other elements. Alternatively, they simply provide further functionalities to other components by means of their API. We'll explore directives in detail in the next section, and also throughout the course. You must be wondering why we've created this host or parent timer component with no implementation. Soon we'll flesh it out with some other features, but for now let's use it as a proof of concept for how to initiate a component tree. You'll probably agree on the fact that having the functionality of setting up custom countdown timers would be nice, right? Input properties turn out to be an excellent way to achieve this. In order to leverage this functionality, we'll have to tweak the import statement at the top of the file. Go to countdowntimer.ts file, and in the import statement, add the keyword input. Also modify the code in the countdown timer component class. You might have already noticed that we're no longer initializing the seconds field, and it's now decorated with a property decorator. We've just started to define the API of our component. Property naming is case sensitive. The convention enforced by Angular is to apply camel case to component input, and, as we'll see shortly, output properties alike. Next, go to timercomponent.ts file and just add the desired property in our container components template. Please note that we've not updated the timer component at all. We only updated its countdown component child component. However, its brand new API becomes available to any component that eventually includes it in its own template as a child component, so we can set up its properties declaratively right from the template, or even bind a value imperatively from a property located in the timer component controller class if we wish. When flagging a class property with input, we can configure the name we want this property to have upon instantiating the component in the HTML. To do so, we just need to introduce our name of choice in the decorator signature. In any event, this practice is discouraged since exposing property names in the component API distinct from the ones defined in its controller class can only lead to confusion. Now that our child component is being configured by its parent component, how can we achieve communication from the child to the parent? This is where custom events come to the rescue. In order to create proper event bindings, we just need to configure an output property in our component and attach an event handler function to it. In order to trigger custom events, we'll need to bring event emitter to the party, along with the output decorator, whose functionality is exactly the opposite to what we learned regarding the input decorator. Let's import output and event emitter packages. Event emitter is the built-in event bus of Angular. In a nutshell, the event emitter class provides support for emitting observable data and subscribing observer consumers to date changes. Its simple interface, which basically encompasses two methods, emit and subscribe, which we'll see later. It can therefore be used to trigger custom events and listen to events as well, both synchronously and asynchronously. For the time being, we can get away with the idea that we'll be using the event emitter API to spawn events that listener methods in the components hosting our event emitting component can observe and attach event handlers to. These events acquire visibility outside the scope of the component through any of its properties annotated with the input decorator. Let's add the output decorator just below the input decorator in our countdown timer component.ts file. At the end of the file, we use the emit method. So, this shows an actual implementation that follows up from the previous example. You can notice here that a new property named complete is conveniently annotated with the event emitter type and initialized on the spot. Later on, we'll access its emit method to spawn a custom event as soon as the countdown ends. The emit method needs one mandatory parameter of any type, so we can send a data value to the event subscribers or null if not required. Now we just need to set up our host component so that it will listen to this complete event, or output property, and subscribe an event handler to it. For this, go to the timer component, and the property complete here as well. Also, add the host component within the timer component. Why complete and not onComplete? Angular provides support for an alternative syntax named canonical form for both input and output properties. In the case of input properties, a property represented as seconds could be represented as bind seconds without the need for brackets. With regards to output properties, these can be represented as onComplete instead of complete. That is why we never prefix output property names with an on prefix, since that would occur on output properties such as onComplete, in case we eventually decide to favour the canonical syntax form in our project. We've learned to use input data with our component. The data would live in the container, and the component would be rendered inside of the container template. This means the component could suddenly gain access to the container's data by us typing the container, property, and property on container. And on the component side, the component is the input decorator, and the property is seconds. We've also learned about output, that is, how to communicate back from component to container. To make this happen, we added another property on the component, event and method on event with the property. And on the component side, we would instead use a decorator called output. We used the event complete and the event emitter. And to actively invoke the bonded method, we used the emit method and passed a null value to it. The next thing coming up is to learn how to pass data from component to container. Now that we know how to emit custom events from our component API, why don't we take a step further and send data signals beyond the scope of the component? We already discussed that the emit event of the event emitter class accepts in its signature any given data of the type represented by the T annotation. Let's extend our example to notify the progress of the countdown. Why would we ever want to do this? Basically, our component displays on screen a visual countdown, but we might want to watch the countdown progress programmatically in order to take action once the countdown is finished or reaches a certain point. Let's update our timer component with another output property that matches the original. And now, we emit a custom event on each iteration of the seconds property. Now, let's rebuild our host components template to reflect the actual progress of the countdown. We already do so by displaying the countdown, but that is a feature handled internally by the countdown timer component. Now, we'll keep track of the countdown outside of this component. Add a progress event right here. Next, we add a timeout event. This will be a number property, which also add to our timer component class. Here we took advantage of this round of changes to formalize the timeout value as a property of the host component. This allows us to bind new values to that property in our custom event handlers, as we did in this example. Rather than binding an event handler method to the progress handler, we refer to the event reserved variable. It's a pointer to the payload of the progress output property that reflects the value we pass to the emit function when executing this .progress.emit. In short, event is the value assumed by this .seconds inside countdown timer component. By assigning such a value to the timeout class property within the template, we're also updating the binding expressed in the paragraph we just inserted into the template. This paragraph will only become visible when timeout is lower than 10. What we saw in this video till now was how we could send data from the component to the container. There are essentially two ways of doing that: assign event to the container property and invoke the container method with event as the function parameter. Here's the first version, is what we demonstrated. With the component invoking as progress.emit, with this .seconds passed to the emit method as the data. The second version is a small rewrite of the previous example, where we change the progress to onProgress, with the event passed to it. We would invoke it the same way in the component, but the difference would be that we need to declare a container method, onProgress, so the timeout property gets set that way instead. Let's add the container method, onProgress. Now to have local references and templates, let's flag the instance of our countdown timer component in the timer component template with a local reference named hashCounter. From that very moment, we'll be able to directly access the component's public properties, such as seconds, or even bind it in other locations in the template. This way, we do not even need to rely on the progress event emitter or the timeout class field. We can even manipulate the value of such properties. Besides the input and output decorators, there's an alternative syntax where we can define input and output properties in our components by means of the component decorator. Its metadata implementation provides support for both features through the inputs and outputs property names respectively. Let me show you how we could implement the countdown timer component API. In your timer component.ts file, outside the template, add the inputs and outputs parameters. And in the counter timer component, remove the input and output decorators. And just add it as just the property name and the type. All in all, this syntax is discouraged and has been included here for reference purposes only. In the first place, we duplicate code by defining the names of our API endpoints in two places at the same time, increasing the risk of errors when refactoring code. It's also common convention to keep the decorator implementations as lean as possible in order to improve readability. I strongly suggest that you stick to the input and output decorators.